Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll be looking at how to derive the generation function for the sequence an equals 2 raised to power n. All right. So, okay, let me try to do, yeah, something like this. An equals 2 raised to power n. How do we derive the generating function for that sequence? I have a whole playlist on generating function, though it's still on, but I think we should take some examples to drive home all the points we've been talking about all along. So let's go to derive the generating function. Hmm. Function for the sequence an equals 2 raised to power n. So, we have to remember to use the definition. We use the definition of a generating function, which is a formal power series, which is a formal power series. G of x, guess I want to change that. That's G of x equals summation from n equals 0 to infinity of an x raised to power n. Okay, so that's the formula, right? So in this case, we now have an. So if for an, which is equal to 2 raised to power n, it means that for an equals 2 raised to power n, g of x now becomes summation from n equals 0 to infinity of 2 raised to power n, x raised to power n. So that's what we have right now. So we can tidy that up to have g of x equals, okay, I mean, that's the first thing we have, right? Then let's proceed to other things. And then we have g raised to power x equals summation from n equals 0 to infinity of 2x all raised to power n, because they have that power n in common. So, I mean, from what you can see already, right, this is like, this is 2x raised to power 0 plus 2x raised to power 1 plus 2x raised to power 2. And that goes on, you know. Um, and then that's like 1 plus 2x plus 2x squared, and so on and so forth. That'll be 2x cubed and the rest of them. So now, what if we consider the sum to infinity for this particular kind of expression? So, that'll be, it's a geometric series from all indications with first term is 1. The common ratio is actually 2x, all right? Because we keep multiplying uh, every succeeding term by 2x. So from that, right, we can now get from that we get that g. Okay, I mean, if we take r plus 2x, no. Let's say, yeah, what we'll have, we have there actually, that's g of x now will be equal to sum to infinity. So the sum to infinity for that that's what our gx is going to be like. And that will be first term all over 1 minus common ratio. So the first term is 1 all over 1 minus the common ratio is 2x. So in this case now we can see that we can actually express g of x as 1 over 1 minus 2x. That's exactly what we have. So that's what gx becomes. And beyond that, right, we need to also talk about the point of convergence for this. So now if you look at that, right, you can see that expression um, g of x ceases to exist if 1 minus 2x is equal to 0, meaning that 1 equals 2x, and if you divide both sides by 2, you have 1 over 2 equals x. So x is equal to half. So that means that x equals half says a lot about the convergence of that. So we can conclude by saying that the so I mean what it simply implies is that that generating function only converges for absolute value of x less than half, basically. And that implies that x lies between minus half and half. Okay. It lies between minus and half and half. So we can actually conclude then that we can say therefore generating function, the generating function for the sequence, an equals 2 raised to power n is g of x equals 1 over 1 minus 2x, valid for absolute value of x less than 1 over 2. And that ends it. All right. So that's how to find the generating function of any expression. So all you just need is the an, and then you look at the series, the kind of the sum to infinity of the series that is formed from that, and then you can get your generating function from that. So I have so much of this still coming. Be sure to not miss out on that by subscribing and hitting the notification bell so you can get alerted each time a new video is released. Then comment, let me know how helpful this video is, and let me know if you want to teach a topic or solve a problem. Like and share so that more people can have access to this great content. For those who have subscribed, thank you so much. Bye.